characteristic function, we have defined what is meant of function. We have defined function. Also, we have defined real valued functions. Real valued function. We have seen the properties of real valued function also. Now, I define a specific function. It's called as a characteristic functions. Characteristic function is very simple. Definition is given for this characteristic function. Now, some set A is a subset of S. S is known as a big set. S is known as a big set. Big set. Now, A is a subset of them. We can define the characteristic function. This symbol is used for characteristic function chi. This at A. Now, this function is like a switching circuit. Means if you click the button, then light will be on. If you click again button, light will be off. Either on or off. It will be not in the middle step. Similarly, we have this characteristic function. If you take any point from this set A, now we have to define the domain and codomain for this characteristic function. Characteristic domain will be the complete this set. Domain will be A will be the domain, and codomain contains just two elements, 0, 1 and 0, or 0 and 1. 0 and 1, these are the two elements in the codomain. Now, if you take any element from A, this will be S to S. This function from S to S. Domain will be S. Okay. Domain will be S. Now, if you take any element from A, which is a subset of S, then it is in the A, the value will be 1. If it is not in the A, then value will be 0. Actually here, A and B are the complements of 2. Means if you take the A union B, that is equal to S. Means X belongs to A, then value of this function will be just 1. And if X is not belongs to A, then characteristic value of this function will equal to 0. This types of function whose codomain, that is image that contains only two elements, 0 and 1, is known as characteristic function. These functions satisfy some important properties. We can verify these properties that chi at A union B is equal to max of chi of A, chi of B. Similarly, chi intersection B, the minimum of chi of A, chi of B is equal to chi of A into chi of B. Similarly, in chi at union A union B is equal to chi of A minus chi of B. And similarly, you can define the function. If you consider the complete set, yes, which is the domain as a characteristic function, then value will be always 1. And if for null set, it is a 0. Means we have defined these are the improper functions, known as improper characteristic functions. Now it can be easily verified for this function. If you take any element, suppose there is some elements belongs to A union B, then it will be either belongs to A or belongs to B. This indicates X will be either belongs to A or X will be belongs to B. Then chi of this A at X will be just equal to 1, or chi at B at X will be 1. Means if it belongs to A and it not belongs to B, then it will be 0. The maximum value, you can take the maximum value of both of them, then it will be given. You will find that if you take this function, it just equal to this thing. Similarly, you can take the maximum value function of these two. You will find that it is again belongs to X union B. It can be verified just mathematically. This is just a characteristic functions we have defined now. We can see. Similarly, you can prove this step also. Means this property you can verify. Okay, thank you. This is the characteristic function.